Today, we are going to discuss Laplace's nebular theory, one of the earliest scientific explanations for the origin of our solar system. This theory, though old, played a very important role in shaping our understanding of planetary formation. Laplace's theory was proposed in 1796 by the French mathematician and astronomer Pierre-Simon Laplace. It is popularly known as the Nebular Hypothesis. The main idea was to explain how the solar system originated using principles of physics and astronomy instead of mythology or philosophy. This was a big step in the scientific study of the universe. According to Laplace, the solar system began as a hot, rotating gaseous nebula. As the nebula contracted under the force of gravity, it flattened into a disc-like shape. The sun formed at the center, while the surrounding material organized into rings. These rings eventually condensed to form the planets. This provided a logical explanation for why all planets revolve around the sun in a particular direction. Let us go step by step through the process. In the beginning, there was a huge gaseous nebula. The nebula began cooling down, causing it to contract. As it contracted, its rotation speed increased, just like an ice skater pulling in their arms. Due to centrifugal force, rings of gas were thrown off from the equatorial region. These rings eventually condensed to form planets and moons orbiting the central sun. This sequence gave a very mechanical and scientific explanation for planetary formation. Laplace's theory was revolutionary for several reasons. It was the first scientific explanation of the solar system's origin. It successfully explained why all the planets revolve in the same direction around the sun. It also explained why the orbits of planets are nearly circular and coplanar. In short, it gave a structured scientific basis to understand planetary systems. However, the theory had some important shortcomings. It could not explain the distribution of angular momentum. The sun holds most of the solar system's mass but very little of its angular momentum, whereas planets have much more. It was later found that planets probably formed through planetesimal and dust accretion models, which are more detailed than Laplace's simple rings. Overall, the theory was too simplistic compared to modern astronomy. To conclude, Laplace's nebular theory was a milestone in cosmology. It was the first attempt to scientifically explain the solar system's origin, moving away from mythological ideas. Even though it is outdated today, it laid the foundation for modern theories of planetary formation. Thus, Laplace's work holds a very important place in the history of astronomy.